So same paper, January 2018. The structure of a compound G is given. You can see CH3, NH2 is there. What is the systematic name of this compound G? So whenever we are giving a priority, we give the priority to the amine group. Okay. When we have methyl and amine, so we give priority to the amine group. So when I count, like example, I can count one. I can start with this one, but 1, 2, 3, 4, 5, 6. If I count in this manner, if I count this as my one, the branch, but I have to include, like, because the priority group is amine group, so I should include the amines in the closest number. So if I count like this, 1, 2, 3, 4, 5, 6. So methyl group is there, but amine group is coming at 4 or 5. So that is not correct. So if I start from here, 1, 2, 3, 4, 5, 6. So first position and third position, I have amine, and fourth position, I have a branch methyl. So it is 4 methyl. And which position we have amine? First and third position we have amine. So it is 1, 3 di amine. Is it clear? This question? The systematic name. Okay. Then the next part, mostly is all about organic chemistry. What is organic species form in a reaction between compound G and excess of ethonyl chloride? So if we have ethonyl chloride, remember, look what happened, like when we have NH2 and this ethonyl chloride is there, which is CH3, C double bonded with ONCl. So this is partial negative, partial positive. This is in NH2, NH is partial negative and hydrogen is partial positive. So this part, C double bonded with O, will displace this hydrogen. So as a result, it will displace the hydrogen. As a result, it will produce C double bonded with O and CH3. So it will produce an amide. Remember, whenever amine react with ethonyl chloride, the product will be amide. So we have to check, like this will also form amide and this other one will also form amide. So we have to check which one is right. So in which amide is formed. So this is wrong, totally wrong. This one is also true. In this one, amide is there, but you can see the order, they change the order. Like first NH was connected, NH2 was connected, now they connected CO. So order does not change, it remains in the same order. So D is the right answer. Is it clear? Look, whenever ethonyl chloride is a simple reaction between ammonia. Like example, if we have ammonia NH3 and ethonyl chloride CH3, C double bonded with O and Cl. So in ammonia NH3, NH2 is partial negative and H is partial positive. And in ethonyl chloride, CH3C double bonded with O, that is partial positive, and chlorine is partial negative. So they displace, they switch the position with each other. So what will form? NH2 will be there, then C double bonded with O, and then CH3. That is called amide. So whenever amine react with ethonyl chloride, it will form amide. So same thing happened here, that we have NH2 and that is reacting with CH3, C double bonded with O and Cl. And in NH2, NH1 of, like NH is partial negative and H is partial positive. And this part is partial positive, chlorine partial negative. So when they displace, this C double bonded with O and CH3 will be attached. So this will be, one of the hydrogen will be removed. and then C double bonded with O and Cl will be attached. And same thing happen. One of the hydrogen will be removed, C double bonded with O and CH3, not Cl, CH3 will be attached. So this is what form, or I can say NHCOCH3. So which option I have? NHCOCH3. That is in option D. That's why D is the right answer. Four different compounds are there, P, Q, R, and S. They have a structural isomers, C9, H10, and O2. Which compound does not exhibit optical isomer, but does react with sodium hydrogen carbonate to give a colorless gas? So first you have to, sodium hydrogen carbonate means it should be acid group. So we have to check which one is an acid group, because acid can react with sodium hydrogen carbonate. So either R can be an answer, or this is ester, this is ester, this one is also an ester. So ester does not, this is acid carboxylic, this is also carboxylic. So R and S both can react with acid, but it does not have geometrical optical isomer. Optical isomer means no chiral carbon, or the carbon which is present should have bonded with different atoms, or should not be bonded, because to be a chiral carbon, it should be bonded with different atoms. So this cannot be a chiral carbon. This is CH2, cannot be chiral. This is CH2, cannot be chiral. This cannot be chiral carbon. Because why it cannot be chiral carbon? Because identical groups are attached to it. So in a benzene ring, there is no chiral carbon. As you can see, all are identical. So R is the right answer. About this one, when we check here, this is a chiral carbon. Why? Because one side hydrogen, one side methyl group, one side acid group, and one side benzene group. So this is a chiral carbon. Is it clear, this question? Then the next one, which of the compound react with sodium hydroxide to give sodium benzoate? So, because basically sodium hydroxide to give sodium benzoate, the idea is that if we react with them, like this is carboxylic acid. Carboxylic acid react with sodium hydroxide. So it will be like if I write a simple for a reaction of carboxylic acid with sodium hydroxide, if we have, say, ethanoic acid react with sodium hydroxide, sodium will take position of hydrogen, so it will form CH3 COO Na plus H2O. So means the part where hydrogen is attached, that will be replaced by metal. So this part, as hydrogen is attached, this will be replaced by metal. But this is not forming a sodium benzoate. Sodium benzoate means, like with a benzene ring, there should be like carboxylic group should be attached, like CH3, C double bonded with O and OH. That is benzoic acid. And sodium benzoate means CH3, C double bonded with O and Na. So this does not form sodium benzoate, because sodium benzoate means this structure. That is sodium benzoate. So this cannot be. Same thing happen. This can react, but this does not form sodium benzoate. Now for this one, both are esters, P and Q are ester. First, they will hydrolyze, they will break down. And when it will break down, because remember when ester break, they will break down from here. One side will become alcohol, another side will become acid. Or you can break from this side, like C double bonded with O and O. See, whenever ester break down, any ester is there. So if I say which alcohol and which carboxylic acid is formed, so if I break from the side of oxygen, the side which is with their oxygen, hydrogen will be attached, so that will become acid, CH3, C double bonded with O and OH. And the other side will become alcohol, so CH3OH. This is how the ester break down into acid and alcohol. So same thing, if you see the two esters which we have, these are the two esters which we have. First, when it break down, it will break down from this part, okay? Like this won't be there. And it will convert into acid first. So this will convert into carboxylic acid first. So H will be attached. And then it reacts with sodium hydroxide. So when it reacts with sodium hydroxide, sodium will take position of hydrogen. So as a result, what it will form? It will form sodium benzoate. But for this one, where the bond will break from here only. And this will turn into phenol, because one side OH will be attached, one side H will be attached. When a hydrolysis of the ester happen, the bond will break from C double bonded with O and O. So bond break from here. This side H will be added, so become acid, and the other side OH will be added, become alcohol. Is it clear that compound P will be the right answer for formation of sodium benzoate? Next is a reaction sequence is shown. First we have like ketone is there. Sorry, CH3, yeah, ketone is there. Then it converts into carboxylic acid. CH3, C double bonded with O. And then it is converted into ethonyl chloride, like ethyl chloride. And then it converted into amine. What is compound W? So it should be secondary alcohol, because secondary alcohol can be oxidized. That's right, B is the right answer. Then which substance what substances are required in step 2? Step 2, we are producing from a ketone, like initially we were having a ketone, and we are converting into carboxylic group. So ketone to carboxylic group, acidified, that does not work. Why this does not work? Acidified potassium, because it cannot be oxidized. Like already ketone cannot be oxidized. Iodine in alkali and followed by hydrochloric acid. This will work. How this will work? Look, when we add iodine in alkali, so this is working when methyl group is there next to carbonyl group. CH3 is there. I'm writing as a structure of this. Then CH2 and then CH3. When I add iodine in a carbonyl, iodine in the presence of, in the beginning, iodine solution is added in alkali. So what will be the product? So that is the triiodomethane reaction. So if you remember, and we are adding NaOH plus iodine molecule is there. So it will form CH3, CH2, C double bonded with O, ONA. plus then it produced that triiodomethane, which is like 3-iodine will be attached, and this H will be there. This is a product which is formed. And then we are doing acid, like we are doing acid hydrolysis. So this ester salt, because this is CH3, CH2, C double bonded with O negative, and Na is positive. And we are doing acid like HCl is there, so H is plus and Cl minus. So this H will be attached here. So as a result, what it will become, CH3, CH2, C double bonded with O, and OH will be there. So it will turn into carboxylic acid plus sodium chloride. So it means first we'll use a triiodomethane reaction. So that's how ketones, aldehydes or ketones can be converted into. Aldehydes can be directly oxidized, but for ketones, we can convert them into carboxylic acid. If it is if a methyl group is there next to carbonyl group, then those ketones can be converted into carboxylic acid by using a reagent mentioned in step 2. So iodine followed by hydrochloric acid, this will give us the result. Is it clear? Part B. Then which reagent in step 3? What we are doing in step 3, carboxylic acid converted into acyl chloride. So we simply want to replace this OH. So if I want to replace this, yeah, so that is a phosphoric acid. PCl5 phosphorus pentachloride is there. That's right. Because if we have carboxylic acid, we add PCl5. So it gives C double bonded with OCl plus POCl3 plus HCl. Misty fumes will be observed. And what is reagent for step 4? Step 4 is what? Look, basically what happened, this is the same idea when we have acyl chloride and we want to produce amide. So there should be NH group should be there. Okay. And then how many carbons are there? One carbon here. Then one carbon, the branch. Then this is CH, this is CH2, and then CH3. Now, how the reaction proceed? Partial positive, partial negative, partial negative, partial positive. So this whole part will take position of a chlorine and chlorine will come out. So basically chlorine will come out. So this is a reagent which we need to convert this acyl chloride into amide. So NH2, CH, CH3, CH2, CH3. What is? So which one the structure matches with? Like NH2, you can see NH2 is attached with the second carbon. Like this is the first, second, third, fourth. So which one NH2? This is cannot be because it's not forming a linear. This one is there because it is NH2 is attached with the second carbon. Here NH2 is an end carbon, so it won't work. It will work, but it does, and even it is already amide. So it's not already amide. Multiple, it will work, like reaction will occur, but it is already amide. So we should add amine group, alkyl amine, so that hydrogen will be replaced by the chlorine and turn into amide. Is it clear? The last part. So this was a paper from January 2018.